Morning. This is lesson 9.2 in your textbook. I was going to do it in 2 parts, but I think maybe what we'll do is just try to do it in one. I really want to get us farther along. I was so in hopes we would be back by now, but I don't know. So in your book, look on page 490 is where we're starting. And this time, so far, we've solved in chapter 7, we solved by factoring. We want to solve quadratic equations today by graphing. And remember, when you do that, what we're really looking for is those x-intercepts. Where does that quadratic equation cross the x-axis? So we're solving by graphing. The first step is to write that equation that you're given in standard form. So it should look like ax squared plus bx plus c equals 0. And everything on the left-hand side, set it equal to 0. And then remember, when we graph that related function, we have the axis of symmetry was minus b, so that x-coordinate, divided by 2 times the leading coefficient. So the coefficient of the x squared term. Minus b over 2a is the axis of symmetry. That's also the x-coordinate of the vertex. We plug that x-coordinate that we just found up here back into this original equation to find the y-coordinate of the vertex. And we indicate that by saying, if x is minus b over 2a, its corresponding value is going to be whatever that function is, evaluated at minus b over 2a. So f of minus b over 2a. The y-intercept, if x is equal to 0, then y is equal to c. So 0 comma c, and then to graph by hand, we're finding another point and sketch it out, find the x-intercepts. In general, if that parabola intersects the x-axis in 2 places, then you have 2 distinct roots, 2 distinct solutions, 2 distinct x-intercepts. If that parabola touches and then goes, you have 1 solution, 1 double root. And if it doesn't intersect the x-axis at all, then you have no real solution. So if you look at example number 1, they gave you an equation x squared plus 2x equals 3. We said that, rewrote it in standard form. We found the axis of symmetry, or I did, I'm trying to move us along a little faster. So minus b over 2a was negative 2 over 2a, which is 1, so axis of symmetry was negative 1. Plug that negative 1 back into this equation and found out the corresponding y value. It doesn't look like it, but that should have been a 4. Was negative 1 comma negative 4. If I set x is equal to 0, I'm looking for that y-intercept, so that was negative 3. Another point, I arbitrarily chose 1, which is a nice one to pick because it turned out that that was one of the roots. Using symmetry, there was the vertex, there was the y-intercept, so I had another point at the same distance on the left-hand side. There was the other point that I found, which was a root. It was 2 away on the right from the axis of symmetry, so 2 away from the left was the other root. And so I have x-intercepts at negative 3 and 0 and 1 and 0, so that means the solutions to my equation are when x equals negative 3 and when x equals 1. Look at monitoring progress. We rewrite them in standard form. The first one, I went through all the work and I found x equals negative 1, x equals positive 2. For the second one and the third one, remember you can do these on your calculator. So the answers for the second one, let's just go ahead and remember how we do it. So in your calculator, put in that equation. So I'm going to my y equals, and I'm writing x squared plus 7x, which would be sort of a nuisance to do, plus 10, because I'm going to get fractions. And then I'm on a zoom 6. I don't know what your window is, but that puts it back in the center. And so you should have something that looks like that. And then we want to find those 2 intercepts. Well, here when I look at them, I don't have to even approximate. I can see that they're negative 5 and negative 2 because they show up nicely on my calculator. And the same will happen for number 3. And I'm thinking I have another one that's not so nice that I do on the calculator. And we'll look at that a little bit later. But if not, then we're good for those. I'm going to pause this for a minute, trying to speed us up and come back and do the rest so you don't have to sit there and watch me erase the board, if I can do. So picking up with example 2, where they gave you an equation, x squared minus 8x equals negative 16. The first thing you want to do is put it back in standard form. So x squared minus 8x plus 16 equals 0. Find the axis of symmetry, that was 4. Find the vertex by plugging 4 back into this equation and find 0. Well, right away when you graph it, if your vertex is on the x-axis, that means that quadratic equation is going to intersect in one place, and that means the solution is one solution, one double root, and that x equals 4. If I'm looking at example number 3, negative x squared was equal to 2x plus 4. Put it in standard form with that x squared on the other side. The axis of symmetry was at negative 1. The vertex, when I plug negative 1 back into that formula, the vertex was negative 1 comma 3. When you graph that, that vertex does not, means that that parabola does not intersect the x-axis, and that means there is no real solution. Another way to solve these, if I've got factors on both sides, is with your calculator. So in your calculator, you could put y sub 1 equals negative x squared, and then y sub 2 equals 2x plus 4, and then zoom 6 to put it back in that standard window. What you're looking for is where those equations intersect. You want the x value of the point of intersection. Well, in this case, those equations did not intersect. There are no points of intersection until another way of seeing that there was no solution. Look at monitoring progress. This is at the bottom of page 491. I didn't work these out for you. You can, while we're doing these, you need to be able to do it by hand. But when we're doing so many of these, I don't mind if you use your calculator to look for those roots. Just make sure that you remember, you can find the axis of symmetry, you can find the vertex, you can find the y-intercept, you can find another point. So you would graph it by hand if you had to. So monitoring progress for number 4, you can pause here, go work them and see what you got. X was 6, there was just one distinct root. For the 5th one, x was 0 and x was negative 4. That's where that parabola crossed the y-axis at 0 and it crossed the x-axis at 0 and negative 4, which made that equation have a value of 0 when x hit those values. And it's the zeros. For the 6th one, x should have been negative 5. The 7th, there was no real solution because that parabola did not cross the x-axis. For the 8th one, x was negative 6 and negative 1. And for the 9th one, again, no solution. Let me pause here and go do the rest so you don't have to wait for me. I'm trying to speed us up. Hopefully this works. Okay, so remember, in general, you have 2 solutions. If you have 2 x-intercepts, so your parabola intersects twice. You've got 1 solution. If you have 1 x-intercept, that parabola just touches it and goes back up. And you've got no real solutions if the parabola does not intersect the x-axis at all. The textbook problems 1 through 28 go with the examples that we just talked about. Remember vocabulary. A 0 of a function is an x-intercept of the graph of the function, and it's a root of the corresponding equation. So zeros, roots, and x-intercepts all mean the same thing. Look at example number 4. We're finding zeros of a function. So remember, if you're given the graph and you're asked to find the zeros of that function, what you're really asked to find is where does that graph, what are the x-intercepts? Where does that graph cross the x-axis? So if you look at the picture, this is on page 492 in your textbook. Look at that picture and look at the graph and see that it's crossing the axis at negative 1 and again at 2 and at 3. So this is a cubic equation. Cubic equations have 3 roots or a maximum of 3 roots. And all you're doing when you're finding those is you're looking at the graph. Where does it cross? Solutions are x equals negative 1, x equals 2, x equals 3. It can't be easier than that. If I'm looking at example 5, notice that zeros are not always integers. In fact, often they're not. And so for example 5, it's asking you to approximate those roots because when you graph it, notice it's close to being at -4, that first one, and somewhere between -1 and 0, but from your graph, from your calculator, you can't tell exactly where it is. One of the things they wanted you to look at, if you made a table of that, so take your calculator, put that equation in, so I'm going back to the y equals, and I'm putting in the equation x squared, and I want you to do it too so you can see what we're talking about. So x squared plus 4x plus 1 on a slow typer, and you're graphing it. Zoom 6 if you don't know where your window was. You're graphing it, and you get the graph that they're showing you in your textbook. Should look like that. And then look at the table of values. So go to second table, second graph, and notice you've got sign changes in between -4 and -3. Sign change means that you found a root somewhere between -4 and -3, and look and see where the next sign change occurs is somewhere between -1 and 0. So I'm going positive, then to negative, then to positive. If we want to find the approximation using our calculator, I'm going to second calculate, so second trace, and we're looking for number 2 zeros. And it's going to ask you for the left band. Remember, so here's this. Well, it doesn't look like that. They're both negative. So I've got those zeros. It's looking for a left band. This is an opening up parabola, so this is my first left. This is my first right. And you must be on one side or the other because what your calculator is doing is using those sign changes to interpolate and get close to that root. So if I take my arrow key and toggle over, this is the first one we're going to find. So toggle over there, put your cursor so it's a little above the root. So it's asking for left band. When you get your cursor up here, say press enter. It's asking for the right band, so take your arrow key and get a little below, press enter. And it's going to say guess, press enter again, and out should come -3.7 if we use just a single decimal approximation, which is what I think your book did. Did they do that? Yeah. So -3.7. And if I want to find that, it doesn't matter. Usually I would do 2 digits. If you want to 2 decimal places, if you want to be more precise, I'm just trying to match what your book did. To find this one, you have to do the process all over again. So I'm entering again, second trace to calculate. I'm picking zeros again, and this time I'm taking this over here again. This is the left, and this is the right. We read left to right. So the left one is the first one when it opens up, the first one that you come to. So I'm toggling over until I'm a little below that X intercept. I press enter, I toggle till I'm a little above, I press enter. For the guess, I press enter again, and out comes 0.26, so I would make that about 0.3 if I can, if I'm rounding to 1 decimal place. Negative 0.3. If I'm rounding to 1 decimal place. For monitoring progress, use your calculator and see. For the first one, you can pause here. I don't want to take the time to do this. I'm trying to speed us up. Trying to come from more ground than I think we're going to get to. So they gave me an equation. I'm graphing. I'm looking for those zeros, and I found them. I didn't have to use interpolation. I could just look and see at my graph. X was -3, and X was +2. Those were the 2 zeros. For the other one, I couldn't tell from the graph exactly where it crossed, so I'm going to let my calculator do that calculation for me. And approximately at -0.7 was 1 on the left, and on the right-hand side, X was approximately 2.7 if we just rounded to 2 decimal places. Look at, so that was 10 and 11. Look at your graph, or look at the solving a real-life problem. I wasn't going to do the work for this one, so because your book did it step by step, and I think at this point we're pretty good. So look at the words. You've got a football player kicking that football 2 feet above the ground with an initial vertical velocity of 75 feet per second, and they give you an equation. that represents the height in feet after some time t in seconds. And it wants you to find the height of the football each second after it's kicked. Well, use your calculator. So put in that equation, use that table of values, and they have theirs shown in the textbook, that little column on the left-hand side. And that's what they say, make the table of values, starting with t, and continue until you find the function value that's negative. So they found that their first negative value was at 5 seconds looking at that. And then for B, from part A, you can estimate that the height of the football is 50 feet between 0 and 1 second, and between 3 and 4 seconds. That means it comes up and it comes back down. To determine when the football is 50 feet above the ground, find the t values, the time for which h is 50. So it solve that equation by graphing. I'm setting it equal to 50, which means I'm moving 50 over to the other side. So what you're putting in your calculator is negative 16t squared plus 75t minus 48. I'm moving it all to one side, just like they did. And then graph, and I'm looking for where it's between 50 feet. And then monitoring progress, and that brings us to the end of this lesson, which I think is pretty straightforward and an easy one to do. So homework will be not a worksheet this time. There'll be textbook problems, and I'll put those on my school app, and I will hopefully see you in person sometime. But otherwise, this was 9.2.